Hi everyone. In my previous lecture, I have covered what exactly number is, how to represent a number, and we have even defined the number system, and we have seen the radix, what exactly the radix of the number, as well as the positional values of the number system. Now, in this lecture, we are going to see the types of number systems. There are so many types of number systems, but here I am mainly concentrating only on the four number systems. The first one, what we call it as your decimal number system, and binary number system, octal number system, and hexadecimal number system. So what a number system is going to have means the total number of digits which are going to have in the number system, what is the rad or base, and the positional values that we are going to discuss by giving an example for the given number system. Now let us proceed with the first one, that is the decimal number system. As we are well versed with your decimal number system, that we know that the decimal number system is having the numbers from 0 to 9, as we are aware about the decimal number system. And we have also said in the previous lecture that the base of the number system is 10, and it is having the positional values as 10 power 0, 10 power 1, 10 power 2, etc. in the integer part, the positional values, and 10 power minus 1, 10 power minus 2, and so on your fractional part. So this number, as we have said previously also, that a decimal number is always represented with one base at the bottom. So I can say that this is the example of your decimal number system. So the positional values of your 4 is 10 power 0, and positional value of 0 is 10 power 1, and positional value of 1 is 10 power 2. And coming to the fractional part, the positional value is 10 power minus 1, and for 8 it is 10 power minus 2. So whenever I want to represent a decimal number, the number is indicated with the base at the right bottommost part. So in a decimal number system, we are having 0 to 9 numbers with a base 10 having the positional values in the power of 10. Likewise, now if you see the binary number system, as the name itself says that it is having two digits, that is 0 and 1. That's why the base of the number system is 2. And as we have discussed in the previous lecture, saying that the positional values are nothing but it is defined in terms of the base of the number. So here also the base is 2. So we are giving the positional values as the power of 2 for integer as well as fractional part. And the point which is separating here, this is called as binary point. And now coming to the example, if you want to represent a number in the binary number system, now I am taking an example. So this is an example of your binary number system. So it is having 1101.110. This is a number which is represented in your binary number system. So whatever the number I want to represent in a binary number system, it contains only two values, that is 0 and 1. By representing a base at the right bottommost part, it gives that this number is a binary number. If you are not representing the base, so automatically we can take this number as a decimal number system. So whenever I want to represent a number in binary number system, 100% we need to represent the base as at the right bottommost point. Now coming to the next number system, what we have here is the octal number system. So in an octal number system, the name itself says that the octal means it is having 8 digits. So these days 8 digits are 0, 1, 2, 3, 4, 5, 6 and 7. The total number of digits which are present in the number system, that gives the base. So the total number of digits which are present in the number system are 8. So base of that particular number system is 8. And coming to the positional values, as we have said, it is nothing but the power to the base. So it is represented as integer part 80, 8 power 0, 8 power 1, 8 power 2 and so on in your integer part. And coming to the fractional part, it is in the powers of minus, that is 8 power minus 1, 8 power minus 2, 8 power minus 3 and so on. Now giving an example of your octal number system. So number should not exceed the 7 value. So 1, 2, 6.14 with base 8. When you are representing the base, then only I can say that this is a octal number system. Otherwise, by default, I can take it as a decimal number system. So without representing the base, the number always says that it is a decimal number, but whenever you are representing a base, that shows that the number belongs to the octal number system. Now coming to the hexadecimal number system. Hexadecimal number system means it is having total 16 digits. That is, here this particular number system is having both the numerics as well as alphabets. So the numbers whatever we are having 0 to 9 are as usual like your decimal number system, but after 9 we need to have a 10 here, but in place of 10 we are taking it as A, for 11 as B, for 12 as C, for 13 as D, 14 as E and 15 as F in your hexadecimal number system. So whenever I want to represent a number like 10 in your hexadecimal number system, that shows an A in your decimal number system and it is having a base as 16. And the positional values are in the integer part. When we start from your LSB, it is 16 power 0, 16 power 1 and so on. When it is reaching the MSB, the maximum value will be the position, whichever the position you are having, that will be the 16 power of that position. And coming to your fractional part, again it is the powers of minus 1, minus 2, minus 3 and so on. Now taking an example here, now I am taking an example. That hexadecimal number system need to have all the numbers, like it can be a mix of alphabets as well as numbers. So 1A 6.1B. So this number system, this is an example of your hexadecimal number system. Not only this one, if I want to write 124.18 base 16, this also represents a hexadecimal number system. It is not having any alphabet, but still, as I have mentioned the base as 16, this number belongs to your hexadecimal number system. Now we'll see the overview of your all number systems. That is, here now as I was saying that I am discussing only about the 4 number systems. So decimal number system, binary, octal and hexadecimal number system. So decimal number system is having the numbers from 0 to 9 and base as 10 and positional values are raised to the power of your base. And binary number system is having the 2 numbers 0 and 1, the base is 2 and positional values are raised to the power of your 2. Octal number system is having the numbers from 0 to 7 and base as your 8 and positional values are raised to the power of 8. Hexadecimal number system is having 0 to 9 and A, B, C, D, E and F, having a base of 16 and the positional values are nothing but it is raising to the power of 16. So this 4 number systems we are going to see in our syllabus. So based on this, we'll see in the next lecture we are going to cover the conversion between the number systems. How we are going to convert one number system to the other number system. Like for example, if I have a number in your decimal number system, how it can be converted to the binary, and in the reverse process if I convert, whether I am going to get the same number or not. Likewise, a decimal can be converted to an octal, octal to binary, again binary to your decimal, when it is in a cyclic fashion, whether you are going to get the same number back or not. So that's why whenever we have defined the number system, we have said that it is an ordered set of symbols with well defined rules. So whenever I am going to convert the numbers from one number system to the other number system, so when I retrace it back, I need to get the original number when I convert back to the same number system. So that's why we are saying that it is having a well defined rules. So each and every number system is having a rules. In our syllabus we will be mostly concentrating on the binary number system, as because the digital electronics only deals with your binary number system. We will be more concentrating on the binary number system.